Combined gas law, lecture 1. As you saw with the laptop lab today, gases respond to different situations. They condense, they expand, they gain pressure when you squeeze them, when you heat them, and the opposite. Now, we're going to talk about ways to measure and calculate what gases will do under different circumstances, changing circumstances. So this is the combined gas law. The formula to write down at the top of your paper here is PV over T equals PV over T, and a lot of people will call it P1 T V1 T1 first situation, P2 V2 T2 second situation. Okay. Now, one way to measure the pressure of a gas, you may not have heard of this, is millimeters of mercury, which means that the atmosphere at that point will support that many millimeters of mercury in a glass tube. And I can find a link probably later to show you exactly what I mean. You can, of course, just Google that yourself. It's a crude barometer for measuring air pressure. That is also called torr. So if you see millimeters of mercury, that's a symbol for mercury. You can also call torr. I call it torr because that's a bit of a tongue twister. And anytime you see that, you're talking about the pressure of a gas. I would write this all down. Now, there's something else to take notes on. Write this all down. Standard temperature and pressure, STP. They mean of the atmosphere, usually at least. Then that will be 1 atmosphere. The standard pressure will be 1 atmosphere or 760 torr, same thing in different units, or 101.3 kilopascal, same thing in different units. This is more for the physics people, but we see it sometimes. And the temperature will be 0 degrees C or 273 Kelvin. And you got to use Kelvin. You must use Kelvin. The problem with Celsius is, think about this. Is 10 degrees Celsius actually twice the heat of 5 degrees Celsius? It's not. But Kelvin starts from absolute 0, where there would be no molecular motion, no heat at all. And that sounds a little unlikely to me, but that's where it starts. And it's set up so that it's 273 bigger in degrees than whatever Celsius is. So 0 degrees Celsius is 273 Kelvin, and 1 degree Celsius would be 274 Kelvin. You got to use Kelvin for another reason too, because Celsius can have negative numbers, and you end up with some crazy answers like negative volume, which I guess means you turned the universe inside out or something. So that would be just crazy. So you got to use Kelvin. Now they'll give you Celsius and they'll ask for it in Celsius, but for the calculations you've got to use Kelvin or you will get it wrong. So let's try number 1. A gas has a volume of 300 milliliters. Okay, for situation 1, that's my volume at 300 millimeters of mercury. Okay, that's situation 1. That's my pressure. What will its volume be? I don't know. Question mark. That's what I'm shooting for, I guess. If the pressure is changed, okay, they didn't have a big story. They just say it's changed. I'll go with it to 500 millimeters of mercury. I'm going to put torr there, and that's my new pressure. So these are kind of just plug and chug. Some people say there's not a lot to figure out. It's not anywhere near limiting reagent with 15 moving parts and all this to remember. You simply just identify the parts, put them in, and start hitting the calculator, or at least close to that. Here's my first pressure. I'll put it there, top, 300 torr. Remember, millimeters of mercury is torr. My volume, 300 milliliters. Now notice there was no temperature, and there's no temperature mentioned at all anywhere, so I'm just going to be able to cross that out, because apparently it doesn't change, and it would just cancel itself out anyway. Even if they told me if it doesn't change, it would just cancel out, so no one cares. Here's my new pressure, remember, 500 millimeters of mercury or torr, and the volume in the second circumstance is what I'm looking for. So remember, the T's are canceled out. I got to get V, this is the X, so to speak, by itself. So I need this to move across the equal sign so I can have V by itself. If it's going to move, and I get this, I get kids doing this wrong all the time, it's got to change levels. So if it's on the top, it's got to go to the bottom. So the calculator work then is 300 times 300 divided by 500, because this is going to move over there. And you should get 180 milliliters. Hit pause, set it up, punch it in, see if that's what you get. I did. I really did it. Number 5. A gas has a volume of 350 milliliters. Okay, situation 1, that's my volume at 45 degrees C. Okay, I can't use that. I got to add 273 to that, and that's going to be 318 K. If the volume changes, okay, not a big story at this time. but they say it changes to 400 milliliters. That's situation 2 changes. What is the new temperature? Okay, that's T2 is going to be my unknown. I don't know what that is. Answer in Celsius. Ah, darn it. Okay, 350 milliliters. I just put it on top. Remember my formula up here. You wrote it